logarithmic functions problems are the ones we want to solve this morning. Now, the problems we have here, we have 5 problems: log 32 base 2, log 27 base 3, log 216 base 6, and 5 raised to power log a to base 5. And the last one is log p to base a plus log 3 to base p. Everything equals to 2.5. Our goal is to evaluate all these problems. Now let's start with number 1. Now, solution. Number 1, there we have log 32 base 2. Now, in solving the number 1 problem, you have to understand the basic principle. We have log 32 base 2. Now we have to understand that 32 is equal to 2 raised to power 5. So we are trying to establish a relationship between 32, that's the number, and the base. So from there we now have log 2 raised to power 5 to base 2. Now from logarithm we know that log a raised to power x to base b is the same as x log a to base b. So these are the basic principles that we're going to apply in solving this problem. So that means we have 5 log 2 to base 2, and also we know that log a to base a is 1. Whenever the number and the base are the same, the logarithm of it is going to be equal to 1. So 5 log 2 to base 2 is equal to 5 times 1, and that is 5. So the answer to log 32 base 2 is 1. That's as simple as that. That is for number 1. Now let's move on to number 2. Number 2 says log 27 base 3 or 27 base 3. Now we also need to understand that 27 is equal to 3 raised to power 3. So we have log 3 raised to power 3 to base 3. Now applying the same law, we have 3 log 3 to base 3. And we know that this 3 log 3 base 3 is equal to 1, so that is 3 times 1, and that gives us 3. So whenever we have a problem of this nature, we must try as much as possible to break the number down to a power multiple of the base. Then we go ahead and solve and apply the relevant laws. Now, number 3, we have log 216 to base 6. Now, we know that 216 is 6 raised to power 3. The goal is to attempt to express the number, that's 216, as a power multiple of the base. So that equals to log 6 raised to power 3 to base 6, and that's equal to 3 log, that's the power comes back, 6 to base 6, and that is 3 times 1, which is what? 3. So log 216 to base 6 is equal to log 6 raised to power 3 to base 6, and that's equal to 3 log 6 to base 6, and log 6 to base 6 is 1, so that is 3 times 1, which gives us 3. That solves number 3 problem. Now number 4, problem number 4 is 5 raised to power log h to base 5. Now there is a law in logarithm that states that p raised to power log q to base p will be equal to q. So the same thing is applicable to this, so that's going to be 5 raised to power log a to base 5. The answer is going to be 8. So this is the law that we must master for logarithm. Now for the last problem, we have log p to base 3 plus log 3 to base p equals to 2.5. Now to solve this problem, we have to realize that log p to base 3 is equal to 1 over log 3 to base p. So this is how they are related. log p to base 3 is equal to 1 over log 3 to base p. So that means we have log p to base 3. Let's take it. This is log p to base 3, which is equal to 1 over log 3 to base p. That means 1 over log 3 to base p will be equal to, we add to log 3 to base p. That's equal to 2.5. Now, to solve this problem here, we have to move forward. To go forward, because this is going to involve a little algebra other than the one that we have been solving now. So we have to say let's log 3 to base p, we go to a particular variable, let's say x. So we can come down here, and since log 3 to base p is x, that means 1 over x plus x is equal to 2.5 can be rewritten as 5 over 2. That's a little mathematical procedure that we have to carry out. Now, at this point, this is 2, this is x, so we can multiply through by 2x. So we have multiplying through by 2x, we have 2 plus 2x squared plus 5 equals to 5. Let me just carry it out so that you understand it perfectly. That means 2x. We are multiplying by 2x because that's the LCM of these fractions. So we have 2x times 1 over x plus x, 2x times x equals to 5 over 2x times 5 over 2. So x cancel out. So we have 2 plus 2x squared equals to 2 cancel 2, so we have 5x. So we have 2x squared collecting like times plus minus 5x plus 2 equals to 0. So that takes us back to quadratic equation. So if we solve this equation quadratically, we're going to have x will be equal to, our x will be equal to 2, or x will be equal to 1 over 2. That is, if we solve this equation, this one quadratically, this particular equation that we've arrived at. So once we get x equal to that, remember that x has been standing for log 3 to base p. So that means, that implies that log 3 to base p is equal to 2, or log 3 to base p is equal to half. So from here we have, from the law of logarithm that stipulates that log x to base a equals to y implies that x equals to a raised to power y. This is the law of logarithm. So we apply that here. That means 3 will be equal to p raised to power 2, or 3 will be equal to p raised to power 1 over 2. Hope we are together. Now, applying that, let's come down. We have, therefore, we solve this one, and we solve this one. We have that p equals to root 3, or to get this one, we take square root of both sides, so we get p equal to root 3. To get p here, we have to square both sides, so that means 3 squared equals to p. So raised to half times 2, so we have p equals to root 3, or p equals to 9. So that is the solution to that problem. Thank you. I wish you all the best.